everyone. Welcome to another session of Triple 205. We'll wait for another few minutes so that other student can join as well. Please go ahead. Hello.
Hello, sir.
Yes, sure. Hello.
Sir, I had some queries related to the quiz on Wednesday.
What sort of actual information do you need?
Sir, what can be the time window or like the slot for the quizzes in from 4 p.m. to 6 p.m. or like this, or we will have only one time?
Um, I have not actually discussed with Tashfin so far. Has he posted anything in like Google Classroom? Probably not.
No, sir.
No, right? He had actually MSc exam, so he was quite busy, yesterday probably. I'll try to actually talk to him, but as he actually said, last time probably our like class test will start after 4 or 4 p.m. or 4 to 5 p.m. and the class test will last for almost 30 minutes to 45 minutes depending on the question pattern we set. But this will not be so difficult. And the lecture up to lecture 6 would be the syllabus probably, as he actually mentioned. But if I cannot actually cover lecture 6, it would be excluded. But if I can actually like cover, then probably yeah, we'll include that as well.
Then it will be up to lecture 5, right?
If I can actually cover lecture 6, probably it should be up to lecture 6, and it would be good for all of you if lecture 6 is included in the exam. Any question? Any more question? We'll wait for another at least two students to join. So then we'll actually start our lecture. If not, probably maybe I can start sharing my screen. So before you start, am I audible? And is my PDF file visible to all?
Yes, sir.
Thank you so much. Thank you so much for your comment. So the last week probably, the last week we had been discussing about the current division rule, the voltage division rule, and other stuff. So we talked about the basic formula for current divider rule. So if I have a current and if I have two parallel branches, that current will be distributed. The current will be distributed actually across the current will be distributed across the two branches, and the current passing through these branches could be given by this relation, like the impedance of the other branches divided by the total impedance, or the sum of the parallel branches actually impedance times the main current, the current which is getting divided into two actually branches, and something like this. But again, what I'm saying, the voltage division rule and current division rules, these are just the special cases. Like when we have series circuit, we can apply the voltage division rule. When we have the purely parallel circuit, we can use the current division rule. But there is no hard and fast like uh, idea, like we must apply the voltage division rule or the current division rule. So what I meant by saying it is you can simply apply the KVL and KCL or mesh analysis or loop analysis, and you will be actually getting the same results. So whatever suits you, you should actually go for that. Unless it's specified in the exam, like use current division rule or voltage division rule, you don't need to actually stick into any actual sort of like specific method of solving solving actually mathematics or the circuit. So if this one is the case, today probably we'll be solving in a few practice problem. So this is one of the practice problem. So if you look at this equation, this circuit, this is actually a circuit with three parallel branches and energized with a the AC source, and the source is actually given here. So all we need to do is to calculate what is the total admittance of the circuit, and we need to draw the admittance diagram, same as the impedance. So previously we have learned the impedance diagram or admittance diagram. There's nothing, but in the complex plane we need to actually plot what is the real value and the imaginary value. That's it. So as well as we need to find what is this current, I mean the main current, and we also want to actually find out what is the current, this current, and this current means the current passing through resistor, capacitor, and inductor. So and also we need to draw the phasor diagram. Finally, calculate the total average power. So if you remember the formula for the total average power, P equal to VI cos theta. So for this one is V is the input voltage, input current times the cos angle between actually voltage and current, and the power factor is nothing but the normal cos theta. This is the power factor. This is the formula. This is the formula we know. So how do we actually solve this? Very easy. First, we'll actually convert this that given AC voltage into phasor format. So what would be that phasor format? 41.42 divided by root 2. Do you understand why did I use root 2? Because we are considering this
Yes,
is as
sir.
RMS value. But somebody actually emailed me last week. Actually he said in some book they use the peak value,
Sadipur.
means yes, there is no actually root 2 divided by root 2, and this is correct. Even in the last class, or when we actually discussed about the phasor transformation, as I said, there is no hard and fast rule. Means you can use it like this. Means 141.42 angle this, but that case you must mention this is a peak value. But for this course we are sticking to the RMS value for the phasor representation. That's why we are actually converting. We're converting it to the RMS value, and later on if we want to actually express it to the time domain, or this sort of actually expression, sinusoidal expression, then again we will multiply with actually root 2. So eventually the final results would be the same. So this is it. Someone's microphone is on. Could you actually turn it off? Or no? Only my there is some noise. Okay, no problem. Let me check. Okay. Some problem was there. All right. If this one is the case, we can calculate the expression for E. means that voltage in the phasor format. Similarly, my target is to convert this one into phasor format. What is the phasor format? This one, R angle 0 degree, right? And
Yes, sir.
so 3.33, then angle is 30 degree. Now, what would be the phasor expression for this one? 1.43 angle would be plus or minus 90 degree. Which one would be the case?
Plus 90 degree.
Perfect. Similarly for this one,
Minus 90 degree. 3.3
perfect.
minus 90 degree.
Okay, 3.33 minus 90 degree. So once we get to know about this resistance, this resistance, this resistance, sorry, impedance for this, and this, we can calculate the total impedance. But since they asked us to calculate actually admittance, and these are parallel circuit, so the easiest thing is to calculate. Sorry, easiest thing is to calculate. Let me check. This one. So easiest thing is to calculate yt equal to y1 yr plus yl plus yc. I need to admit some. This is the total admittance formula. But if somebody says no, I don't want to go for that, he needs to actually calculate the total impedance. So this is the parallel branch. So he needs to actually calculate this one equal to 1 upon ZR plus 1 upon ZL plus 1 upon ZC, then inverse. So when he got actually Z and T total, then YT would be nothing but the ZT. Means the total impedance, inverse of total impedance is actually total admittance. Then we'll get actually a complex number, right? This one will give us a complex number, theta. So I will convert it to A plus IB. So in the phasor diagram, this is the real, this is imaginary part. I will throw A here and B, depending on the sign of A and B, it should be something like this. If both A and B are positive, then it will be here, and this angle is called theta. So this is our target. Second thing is that we need to calculate the current I of t. So I of t is nothing. I of t is nothing but the E divided by ZT, because E is the total voltage, and whatever the equivalent actual voltage we get here, ZT, so that is the current. But if we want to actually express it in terms of actually admittance, we can also write down E times YT, because YT equal to 1 upon ZT. So this is the case. And the third thing is I need to calculate what is the current passing through three branches, resistance, and then inductance and capacitors. There are tons of ways of actually solving this. So first one is what is the voltage across the IR. Since it's a parallel branch, the voltage is still E. So E equal to, we can write down IR times ZR. Is it okay? The
Yes, sir.
voltage
Okay.
equal to the, because it's a parallel branch, right? In parallel
Yes.
branch the voltage would be the same. So same analogy will be applying for the inductor and capacitor, because these are also also in actually series combination, right? Sorry, parallel combination, right? So the number D, as I said, the what is the actually total average power delivered? The formula is VI cos theta. So V is here is E, and I is nothing but this I that we have calculated from here, and then cos theta is the difference between the phasor of this and this. These two phasors actually would give us actually the average power. And finally the total power factor is P equal to sorry, cos theta. Power factor is nothing, the cos theta. Theta is the phase angle difference, voltage as and actually current. But if like this is given, like find the current I of t, it's a sinusoidal, right? So I then theta, later on we need to actually convert it to sinusoidal by writing like this. To because this is a RMS value, phasor is RMS value, so the peak value is root 2 times I, and then we need to write sine omega t plus this actually angle theta. um, do you understand the basic? Because I will show you the workout later on.
So
Do you understand the basic?
previously we wrote vi cos theta v minus theta I.
It doesn't matter. You write actually cos theta v minus theta I or theta I minus theta v. You'll get the same result because cos negative theta and cos theta will actually provide the same answer. Do you understand? No.
We are combining theta v and theta I in theta.
Combining means we are taking the difference and not actually
Yes.
sum it up.
Okay, sir.
Okay. That is the actually formula. So this is the real power. So as I said, this is a workout. It's the simple workout, and you all know this formula, right? We have talked about this formula. So what is the admittance of resistance? What is the admittance of inductance and in the capacitor? We just actually wrote down the formula. You need to go to the actually complex mode in your calculator. um, Whoever is using actually 991 ES or something, that is better than actually MS series calculator, because you can explicitly write down this expression in E series probably, if I'm not wrong. So this calculation is so easy, and as I said, the total impedance should be opposite of actually admittance, or you can actually use my method like calculate the impedance first and then actually take the admittance later on by taking the inverse. So both will actually provide you the same answer. So for admittance, it's a magnitude, and this is the angle, right? This is the RMS magnitude. So this angle is negative 53.13. So it will go to the clockwise direction in the negative side. So this is clockwise direction, clockwise direction, and the magnitude should be 0.5. That's it. It's so simple. And we have already talked about the formula. The total current equal to total voltage, means the source voltage divided by total impedance, and sometimes 1 upon zt is nothing but the total admittance. So whatever you want to use, that should be fine. So um, we did this actually. We did this because this is the RMS value, and these are so simple. Whatever we got here, we convert it to actually sinusoidal form by taking again the peak value by multiplying actually root 2, and these are the actually things. So probably I have said the same thing. So this one is one of the thing, and finally we have plotted this IR. IL and IC means the current passing through resistor, inductor, and capacitor in the actually phasor diagram. How did we do that? Um, First, we need to look at the like phase angle. If it is plus, it will go in the actually anti-clockwise direction. If it is minus, it will go in the clockwise direction. So IR is 53.13, so it's the anti-clockwise direction. Then the IL is negative 36 point something, so it will go down, and the magnitude is around 70. So this is not measured in scale, so this is an approximation. And similarly, there is plus 143 degrees, so this is anti-clockwise, and we just need to draw like this. So I believe this are quite simple. And as I mentioned, for the average power, this is the RMS value, this is the RMS value. So the formula was VI cos theta. If I consider V and I, both current and voltage, are expressed in terms of actually RMS value. And if somebody wants to use the peak value, then the formula equal to VM, sorry, VM, how to erase. So VM IM divided by 2, then cos theta V minus theta I. If somebody writes in theta I minus theta V, the answer would be the same. because the cosine theta I minus theta b and cosine theta b minus theta I will yield the same results. So be careful if you are using actually RMS value, there will be no factor of 2 because Vm by root 2 Im by root 2 means Vrms times IRMS. So this is actually formula, and power factor formula is nothing but the cos theta v minus theta I. So I will be writing this, but as I mentioned in the last class, we must mention whether the power factor is leading or lagging. And what does it mean? I need to check the current is leading or lagging. If current is lagging, the power factor is lagging, and or the vice versa. If current is leading, the power factor is leading. Any question for this math?
No,
And
sir.
if you don't like this method, you just can apply the KVL or KCL, whatever you actually you find it actually convenient. You'll be getting the same results as means rule, and the voltage division rule suggests the voltage across certain actually parameter. Who wants to join now? So voltage across voltage across certain parameter would be equal to that parameter, means that elements divided by sum of the impedance of all elements times the source voltage, which will be divided among, like, the voltage would be divided among other components. So if I have something here and then here, no problem. If I want to calculate what is Z3 and Z4, the voltage across Z4, let's say, equal to V4, then the expression of V4 would be the value of actually of the impedance of that element. So there's nothing but the Z4 divided by summation of all Z. Summation of all Z means all impedance times the main actually voltage, which will be divided among all actually components. So this is the simple actually voltage division actually formula. But again, what I'm saying, you don't need to memorize this. If you are not actually good at memorizing, or not like, if you don't actually find it convenient, the voltage division rule or the current division rule, what you can do is just apply a, like, current loop or the mesh analysis or the loop analysis. For my own actually experience, I never use the voltage division rule or current division rule, because it makes me confused sometimes, like, should I use it or shouldn't I use it. So what I suggest, you can learn, but if you're not actually convenient to, like, find it actually convenient for you, just use whatever like KVL or KCL or anything. So here is an example, a very simple example. I will not actually spend much time on it. So we have a simple actually like series circuit, and using actually voltage distribution rule, we need to find out the voltage across each element, like what is the voltage across the resistance as well as the capacitor. So this actually this voltage is given. Can you please tell me, is it a peak voltage actually representation or RMS value representation? RMS voltage representation means
Peak
this one
value.
is directly peak value. Is there any other opinion?
Sir, RMS value.
Can you explain why?
Because sir, there's the angle given 0 degree. That's why.
Thank you so much. Actually, your answer is correct. This is RMS value because the voltage is expressed in terms of phasor, right? So if it is expressed in terms of actually phasor, if nothing mentioned there, so that is in RMS value. But if it was written like this, 100 sine then omega t plus 0 degree, if it was written like this, then this is peak value, then RMS value would be 100 by root 2, then angle 0 degree. So basically, the representation for this one is 100 times root 2, then sine this. so that the RMS value should be nothing but the 100 and 0 degree. So if this one is the case, as I said, in the last class, we'll be drawing a separate actually diagram, and that is called impedance diagram. So we'll be replacing all the components by impedance, its own impedance, and the phasor diagram. So this is nothing but the 100 0 degree, and we can write down R angle, there is 0 degree angle, and XC angle is minus 90 degree, if I'm not wrong. So these are the actually expressions. So this is ZR, this is ZC. So now my target is to calculate the voltage across ZR and ZC. So again, once ZR, ZC, then you can apply the voltage division rule to get VR and VC. And if you're not actually good at actually voltage division rule and you don't know when to apply, when not to apply, oh, okay, it is mentioned using voltage division rule, that means you must use this. But if it was not mentioned, probably I will try not to actually specify unless it's super necessary. Then you can actually use loop equation. Let's say this is I1, then you will write down the loop equation minus 100 0 degree plus ZR, then I1 plus ZC, then I1 equal to 0. So you will be calculating I1 100 0 degree divided by ZR plus ZC. Both are complex numbers, so you will be write down 100 0 degree divided by ZR equal to 30 degree from here, and ZC equal to 4 negative 90 degree. So if you write down this and use calculator, whatever result you get will be actually giving us the current passing through that circuit or the loop. Now if I want to calculate what is VR, is nothing but the I1 times ZR. Similarly, VC equal to ZC times I1. So in both cases, actually, you'll be getting the same results. You'll be getting the same results, so you don't need to be worried about. But whatever you find it actually convenient, actually just go for that. Similarly, I will not talk about this. Using the voltage division rule, calculating VR, VL, and VC means is nothing but the R L C circuit. Both we have R and then L and then C, but the method would be the same. We'll draw the impedance actually diagram, means the same circuit with impedance. So I will replace this one by ZR, I will replace this one by ZL, I will replace this one by ZC, and this is already been E. So you can use actually voltage division rule as I actually mentioned earlier, or you can use actually loop equation or KVL or KCL, whatever you find it actually convenient to get the final results. Do I need to explain it any further? What do you think?
No, sir.
Do I need to actually explain? Because this is such a simple circuit. So if not, then I will actually move on to another actually topic. Still, if you have any problem, you can ask me. Then we can actually solve it together. So there is another thing we called actually current division rule. We already discussed the current division rule, but let me remind it once again. If I have a parallel branch, then the current will be subdivided into these branches, mean the main current. So you see we have two branches, so this current is dividing into actually two sub branch actually current is I1 and I2. Then explicitly I1 and I2 can be actually calculated like this. I1 means the impedance of other branch, impedance of other branch divided by sum of total actually impedance times the current. Same applies for the I2 and so on. So there is one example, like if we have a current using current division rule, find the current through the each impedance. So we have actually two components, right? So we can calculate what is ZR and what is ZL, and we know current. So what is the current division rule? we'll just apply this, right? IR equal to ZL divided by ZL plus ZR times I. So we know all the value. If I just plug in this value, we'll get the formula. Similarly for the ZL here you check Z ZR, we have calculated ZR in terms of actual phasor, ZL in terms of phasor. Then we write down the actually formula for IR using actually current division rule. So I just plugged in this formula, and whatever we got, this would be the results. Now the question is, can you solve this one using other method? Is it possible to solve this math not using actually current division rule? Do you have any idea?
So KCL.
Okay, yeah, that is good. How many nodes are here? If this is ground, so if I apply KCL at node A, KCL at node A, can anybody help me? Know what would be the expression for KCL here?
So I is equal IR plus IL.
I equal IR plus
IL.
IL. Let's say this is IL. So if this one is the case, what is I? 0 degree. IR means the voltage at A node divided by R 0 degree, right?
Yes, sir.
Or you can write down ZR. That is easy. Then since this node is also A, so I will write down VA divided by ZL. Any confusion? We know ZR and ZL, so from here we will calculate VA. Once we know VA, whatever we are asked to calculate, we can easily actually do. So like I need to calculate what is the IR and IL. So what would be IR? IR would be nothing but the VA divided by ZR, right? Similarly, IL means the VA divided by ZL. Do you understand? Hello?
Yes, sir.
Okay. So if this one is the case, the simple thing, whatever you have learned in DC circuit actually courses, we can apply it here as well. But only thing we must actually deal with actually the phasor representation of voltage, current, and like other steps. And now again, if I have a like using current division rule, find the current through each branches. Do I need to actually explain this one, or you already know, or any idea how to do that? Okay, if you don't have any idea, just check it out. These two are parallel, but you see in one parallel branch it's in series combination. Can I actually reduce it to like this?
Yes, sir.
Let's say this is Z1, this is Z2, this is I. What would be the expression for Z1?
1 plus 890 degrees.
Yes, R plus XL 90 degrees, right? Because it's the inductor, so that would be the case. So 1 R actually 0 degree, 0 degree plus XL value is given 8, angle is 90 degree. If you use calculator, you will get some value, and Z2 equal to nothing but the 2 angle 90 degree because it's a capacitor. So once you know Z1 and Z2, what you can do, you can simply apply the current division rule, means the current flowing through this, let's say I1 and let's say I2. So formula for I1 should be Z2 divided by Z1 plus Z2 times I. Similarly, for the I2. Do you understand? This is the current division rule. And if you don't need to actually current division rule, apply KCL at this point, then you will get the same results. Any idea? Any confusion? Hello?
No, sir.
Any confusion? Workout is given here, so I will be uploading this actually annotated lecture so that you can see this workout. But my suggestion, don't follow this workout blindly, because this is one of the ways of solving actually certain maths. Okay, but you can choose whatever you find it convenient. So don't actually try to blindly copy everything. So then everything will be complicated. Now here are few things. Again, we can apply the knowledge of voltage division rule, current division rule, or something, or simply we'll go for the KVL, KCL in with mesh analysis, node analysis, or whatever we have. So uh, now, so far when we discussed, we either actually select a series circuit or a purely actually parallel circuit. But what if we have a circuit which are in actually series combination as well as actually some parallel combination in a network? So there are many ways again, but you can always use the idea of actually voltage division, current division rules. So here uh, we have a RLC circuit, sorry, RCL, mean RLC circuit, but we need to calculate the what is the voltage across capacitor and what is the current of the source, means the IS. So one of the way which has been actually implemented here, I will actually discuss here, and then I will actually tell you how to solve this one in another actually method, or the easiest one. So in this circuit, again we'll convert everything into impedance. So once we get to know about impedance, this one and this one are in series. So this one and this one are in series, means basically, let's say this is Z2, this is nothing but the E, then angle some theta. Theta degree is here, theta equal to 20 degree. So then if I combine R and C, then we'll get a simple, sorry, Z1 simple. So Z1 equal to nothing but the R1 plus XC negative 90 degree. In confusion here, if there
No,
is
sir.
no confusion, I need to calculate what is the voltage across VC. Now you check, voltage across VC is nothing but the voltage across only only what, this, right? So can you check, this is a series circuit, and voltage across VC using actually voltage division rule equal to ZC divided by ZC plus ZR times E. Do you agree with this statement? This is C. Okay. You see, if I consider only this part, means let's say there is no this part. So this voltage is across this resistor and capacitor. So these are in series. So we can apply voltage division rule, and voltage division rule says the voltage across that capacitor should be impedance of capacitor divided by total impedance which are in series. So ZC plus ZR in series times the source voltage, whatever the voltage we got here. So, and the second thing is we need to calculate current. One of the way of calculate this current is simply, you see that Z2 and Z1 are in parallel. So simply I can remove this one. Sorry, I can remove this one, E theta. So this is nothing but a single source, let's say Z3. So Z3 is nothing but the parallel combination of Z2 and, did I write Z1? Okay, Z1. So Z1, Z2 divided by Z1 plus Z2, that would be the formula. Whatever we got from here, this is the value. Now we know E, we know actually Z3. So that current would be, the current IS would be nothing. The IS would be nothing but the E angle theta divided by Z3. That would be the IS. This is one of the way of solving. But there are another way of solving. If I use KVL here, then let's say, then it would be a loop. Let's say I1 it will be another loop I2. We will actually write down two equation, then we'll be solving I1 and I2. I will not actually discuss it here because um, previously when we actually solve DC circuit, we can use calculator to solve I1 and I2 because it's a two unknown variables, right? Like X and Y. So for our case, it's unknown variable is I1 and I2. We could easily actually get the solution, but now we are dealing with actually AC circuit or complex number. So probably in the next class, I will actually teach you how to solve the complex number in sorry, how to solve a complex equation in like calculator. Like if I have a two equation but in the complex domain, how to solve this actually parameters. So till now this is the easiest way how to solve like using series parallel combination we can actually get this result. So yeah, in one case they actually also use actually current division rule, but again if you understand actually the question properly, you might not to actually use the current division or voltage division rule. So this one is the case. Similarly, this is the last actually math probably. For the given circuit, the circuit we have, basically you can see these two are parallel actually circuit, right? These two are parallel circuit. In that parallel circuit, in one branch we have resistor and actually inductor in series, and another branch resistor and capacitor are in series. All we have to do is to calculate what is the source current and what is the voltage between this node and this node. Again, you can use actually KVL in two loop or in the KCL, you will get the same results. But since we don't know how to solve actually two simultaneous equation in complex plane, we'll skip that one. So right now we'll be actually focusing on what is the voltage division rule or the current division rule or so on. So first for IS is so simple. Can we actually draw this circuit like this? This is E. Can you see my yellow color drawing, or
Yes, sir.
I should choose the other color?
It's
I don't know.
visible.
It's visible? All right, then it's fine. So what I wanted to say, let's say this is E. Can I reduce the whole series branch, means R1 and XL, in terms of a simple impedance? The answer is yes, right?
Yes, sir.
What is the expression for Z1? R 0 degree plus XL 90
490
degree.
degrees.
And Z2 would be nothing but R 0 degree. When I say R, this is R1 and this is R2 plus XC negative 90 degree. Once we get to know Z1 and Z2, we can further simplify. This current is IS, this is E, this is IS. Now Z1 and Z2 are in parallel, so we'll get ZT. What is the expression for ZT? Z1 and Z2 are in parallel, so formula would be Z1 Z2 divided by Z1 plus Z2. Any confusion?
No, sir.
No? So simple. Now once you know ZT and E, what is the expression for IS? E divided by ZT, right? Done? This is one of the way. Another way, these are in parallel. So we'll calculate the admittance of Z1, we'll calculate the admittance of Z2. So if I add up these two, then we'll get the total admittance ZT. And if I take the inverse, then we'll get actually the total impedance. So there are tons of ways of actually solve this. So whatever you like, you can go for that. Now, I need to calculate VAB. So VA is the voltage between this point and this point. VB is the voltage difference between this point and this point. So first, I will calculate what is VAB, means VA minus VB. So I will calculate in a VA first, and then we'll calculate in a VB first. So how to calculate VA? So if you see that E is the voltage across the R and XL branch, do you understand that voltage E is across this point and this point?
Yes,
But
sir.
these 2 points are in series, right? So we can apply, the voltage division rule. So what is with the voltage division rule? ZL divided by Z1, Z, sorry, again Z1 means ZR1 plus ZL times E. Do you understand this? So voltage across this point equal to the impedance of this divided by total impedance, mean the series impedance, this one plus this one, times the total actually source voltage. Do you understand this? Similarly, we will calculate VB equal to ZC divided by ZR2 plus ZC times E. Once you get to know V and VB, then VAB means VM minus VB. This is one of the easiest way to solve everything. Do you understand?
Yes, sir.
Yeah. Here they use actually, there is another way of actually doing solving actually math, and that is called the KVL and KCL. So you have tons of way of solving. So just use your brain, and probably I suggest you to try with different actually method, like whatever you understand, and I hope you will actually end up with getting the same results. Any question here?
No, sir.
No. Then this is the end of actually lecture 6, and I will not go to lecture 7 because it will be quite burden for you now. So I have a question, like, do you have any question regarding today's lecture or the previous lecture that I need to clarify before you appear for class test? And I believe the student mentor, she posted something in Google Classroom. If you have time, please actually consult with her. She might actually help you in understanding certain actually aspect of circuit analysis, as well as the question patterns. So something like this. Yeah. Any questions? Any question? Hello?
No, sir.
No? So good? Or it's a lunchtime? Okay. If you have no question, then we'll actually end our session here. And best of luck for your like class test on probably on Wednesday, and we'll be having another class. So in the next class, if you are having any actually problem regarding solving actually mathematics, or you didn't understand certain part, uh, please feel free to actually discuss with me in the live session. Okay, there will be actually a segment, we'll be solving this actually questions. Yeah,
Sir,
sure.
I have a question.
Yeah, sure, go ahead, please.
Are we going to have any official announcement about the quiz in the Google
Yes,
Classroom?
I couldn't actually make the announcement yet because another teacher, Tashpin Muhammad, um, he is having an MSc exam today. So once he's done, I'll talk to him, and then we'll post in the Google Classroom
Oh,
the
okay, sir.
official
Thank you.
announcement.
Yes, sir.
Unless you get actually official announcement, nothing is final. Means if I will never say, oh, tomorrow is the exam, without actually providing an official announcement. All right.
Thank you, sir.
All right. Do you have any more question? Hello.
No, sir.
Thank you so much. See you again day after tomorrow. Okay. Have a nice day.
Have a nice day, sir.
Assalamu alaikum, sir.
Walaikum assalam.
হ্যালো, আসসালামু আলাইকুম স্যার।
হ্যাঁ, ওয়ালাইকুম আসসালাম। হ্যাঁ, বলেন।
স্যার আমি একটা জিনিস জিজ্ঞেস করতে চাচ্ছিলাম।
অফকোর্স আপনি জিজ্ঞেস করতে পারেন।
স্যার ওই যে 2 ও 3 ল্যাবের মধ্যে তো এখন আমাদের অফলাইনও শুরু হয়ে গিয়েছে, আবার অনলাইনও অনেকে করছে। তো
হুম হুম।
আমার হচ্ছে গিয়ে 2টা মেম্বার হচ্ছে গিয়ে ওরা অফলাইনে করার জন্য চলে গিয়েছে, আর আমার একটু প্রবলেমের কারণে আমি অনলাইনই রয়ে গেছি। তো স্যার এখন যে আমাদের সাবমিশনটা ছিল ওটা তো আমরা অনলাইনে মানে গ্রুপের একজন মেম্বার সাবমিট করতাম, এখন কিভাবে সাবমিট করব স্যার?
আমার সাজেশন হচ্ছে যে আমাদের ল্যাবগুলো হচ্ছে খুব ইজি, ঠিক আছে।
জি
আর
স্যার।
এটা তো জাস্ট সিমুলেশন ল্যাব। আপনি যে কাজ
জি
করেন,
স্যার।
আপনি জিনিসগুলো সিমুলেট করেন।
জি
থিওরি মানে রিপোর্ট যেটা হচ্ছে খুব রিগোরিয়াসলি দেখতাম যে আপনি ঠিকভাবে লিখছেন কিনা, থিওরি ঠিক আছে কিনা। যারা ইন্ডিভিজুয়াল
জি
সাবমিট করবে, আই উইল
জি।
কনসিডার লাইক আপনি যদি থিওরি পার্ট মোটামুটি লিখেন, যদি ইভেন ছোটখাটো ভুলও যায়, দেন আই উইল কনসিডার অ্যাজ লং অ্যাজ
তার
ইউর
মানে স্যার আমি
সিমুলেশন।
হচ্ছে কি ইন্ডিভিজুয়ালি এখন থেকে সাবমিট করে দিব,
এটা
রাইট
তো
স্যার?
আপনার জন্য ভালো। আপনি আপনি আপনার অপশন ভালো, মানে ফর আপনি ভালো পজিশনে থাকবেন গ্রেডিং এর ক্ষেত্রে, মানে
জি
সিস্টেমে।
স্যার। জি স্যার।
ঠিক আছে, এবং
স্যার
এত টাফ নয়। বলেন।
জি স্যার, সমস্যা নেই, আমার করতে কোনো সমস্যা নেই।
এক্স্যাক্টলি।
স্যার আর একটা জিনিস, স্যার আরেকটা জিনিস হচ্ছে গিয়ে যে দেখা যায় যে ওই যে ক্লাসরুমের মধ্যে প্রত্যেক উইকে যদি আমি কোনো কিছু মিস করি তো ওইটা লেখা থাকে সাইডে মিস, আর কোনো কিছু যদি অ্যাসাইন করি তাহলে লেখা থাকে যে অ্যাসাইন।
হুম।
তো স্যার এখানে হচ্ছে গিয়ে যে যেমন ওই যে আমার গ্রুপ মেম্বার্স আমার হয়ে সাবমিট করে দিয়েছে, তো ওইটা তো আমার মিস লেখা হয়ে আছে, তো
বাট
ওইটা থেকে আমি
আপনার গ্রুপ মেম্বার তো হচ্ছে অফলাইনে হচ্ছে সাবমিট করবে। সে তো
ও
সে
হচ্ছে
তো
গিয়ে স্যার
সিমুলেশন
যখন আমার
করে
সাথে
সাবমিট
অনলাইনে
করবে না।
ছিল, যখন আমার সাথে অনলাইনে ছিল গত সাবমিশন গুলাতে, তো
আচ্ছা
ওইটা
আচ্ছা,
তো আমার ওইখানে
ওটা আমরা
ঠিকই
চেক
মিস
করে
লেখা।
নিব। হ্যাঁ, ওটা ওটা
আচ্ছা আচ্ছা,
হচ্ছে
এটা
আমি
একটু
ওই
আমি এটা
সাবা
একটু আমি ক্লিয়ার ছিলাম না এই জন্য
ওটা
আর কি
সাবা
স্যার।
ম্যাডামের সাথে কথা বলে চেক করে নিব। যারা অনলাইনে আছে 6 তারিখের পর থেকে তাদের অনলাইনেরটাই হচ্ছে কাউন্ট হবে শুধু, আর যারা অফলাইনে
জি
আছে
স্যার।
শুধু অফলাইনেরটা কাউন্ট হবে। তো সাবা মিসের সাথে
জি
আমি কথা বলে নিব, সমস্যা নেই, ওটা আপনার কনসার্ন না। ঠিক আছে।
ওকে স্যার। ওকে স্যার। জি।
ঠিক আছে।
আসসালামু আলাইকুম স্যার।
ওয়ালাইকুম আসসালাম, হ্যাভ এ নাইস ডে।
জি স্যার।